All right, this week let's look at how to use case parameter commands to run a design experiment inside LS-Dyna with the help of a few Python scripts. Okay, so the basic problem statement is this. Let's say, for example, I have this component right here, right? This component is filled with an outer sleeve, um, and this component has an inside sleeve and say a cohesive zone model that sort of link them together. What I want to know is what I want to do is to run a design of experiment that is going to sort of look at the relationship between the force and moment I apply to the components, as well as the cohesive zone parameters that's going to hold things together, right? So say, for example, I don't know what kind of bound I need to hold what kind of force in the moments, and then I'm just gonna run a DOE with 6 different parameters, right? And I have my normal and shear stiffness, I have my normal and shear failure threshold, then I have my force, and I have my moment, right? That's the 6 different parameter I'm running, and I'm gonna run say a response surface DOE with 6 parameters, right? That's gonna give me around 53 run with some kind of folding that happens. Now with something like this, you can sort of see this is gonna be a force and moment that's gonna be applied on the backside. I'm going to hold everything together, and I'm just gonna rotate and twist this thing. Basically, that's the nature of the problem. The actual model setup is really pretty trivial, right? I have a few load that's applied. One is a force load, one is a moment load. I'm gonna apply on that CNRB right there, and rest of it is as you would imagine. And I'm run this quasi-statically. Now the key here really isn't to do the simulation here, right? Like when I finish this model, I have a single run. So how do you quickly go through 53, 54 different runs within a single input file? And if you just submit that input file, it will run those jobs sequentially. You never have to worry about it, right? How do you submit a job one time and you never have to worry about it? Now with something like this, what you can do here is first of all to parameterize your input parameters. In this case, I have my load and my displacement, my moment being parameterized. What I also have as a parameter are my ET, EN, FN fail, and FT fail. These are the 6 different parameters that I'm generating. So what you essentially have in this case is a format that looks like this, right? So in LS-Dyna, you can start a case format, which is called a case ID with an associate name, and this is the subcase sub ID. With this, you can do a case begin with a number. That number needs to match the sub ID number, and then you have a case end with that number, same number. So anything that's between case begin and case end are whatever you want the job to look like. In this case, I have my primary input file, which is the input file I have here. If I was simply writing out this job right here, if I just write out this job, that's gonna be my input file. Now within this input file, right, you see this parameter command is gonna define the value of the 6 different parameter that I currently have in the model, not as real values, but as actual parameters. And then what this parameter is going to do is I'm going to feed this 6 parameter value into that input file, and it's going to solve that input file. That's basically how the case and parameter works. And if you just look at this format, it tells you exactly how to work with it. Pretty simple, right? Now the question is this. Now if I have a table that looks like this, right? So let's say I have these 6 parameters. I want to run job 1, job 2, all the way to job 53, all in a single go. What do we do? Right now the key here is I'm just gonna write a very simple Python script that's gonna handle this, and this is essentially what I have. So what happens here is that I'm gonna call the parameter name, the input file name, and then I'm gonna call my output and my input file and my output file. My input file is the CSV file that's gonna be written here. So basically all you have is you take this Excel table and you save it as a CSV file, right? And that's what all you have to do. If you save this as a CSV file, actually just export it, I believe. One second, export it, and you just export this as a CSV file, right? And that's gonna export a file that looks exactly like this. Now that's going to be my input file. My output file is basically a K file that's going to look like it's just going to call like a parameter batch output, right? And then I'm going to use this command to do it. So what I have here, so if I were to show you the actual command for this, right? So I can actually drag it in here. So you see, compared to this one, what this one will look like is that I basically will have a sequential job run goes all the way to 53. You see that? And that's essentially what happens with this Python script. All this Python script does is that it will parse this CSV file line by line and then write them into this kind of format. It's actually very, very easy to do. There's not a lot of point for me to go through this line by line. I have it in the video. If you want to pause the video, you can take a look at it. I have some comments here as well. But basically what it's going to do is it's going to treat the header row as your parameter value. The run is going to be your case ID. And the rest of it is just going to be your parameter values, right? And then it's going to call the same input file because the input file is the same thing. We're just changing the parameter value through 53 different times to run the DOE. Okay, now with these 53 things, once you finish it, what you will see is that basically this is a Python script, and then what you will actually see is a result file that looks like this, right? So you can sort of see this is DOE1, DOE2, DOE3, all the way down to wherever you stopped it. That's what this job is going to do. I stopped this job at 15, but this is what the result is going to look like. And you can actually open the D3 plot for each of these one by one to look at the result for each load cases, right? And all of the result file is going to be located in the same location. And the key here is how do we post-process this quickly? And that is going to be the topic of the next video, where I'm going to use some automated post-processing technique to automate all 53 runs in a single go. So you can write a Python script that's going to interact with LS-Prep post, which is going to generate the result file that we're looking for across all 53 cases, which is going to allow you to be able to post-process all 53 or even more number of cases very, very quickly without relying on an external DOE tool like, OptiSlant or LS-Opt or whatever that might be. For very simple cases, we can certainly write our own script to do so. And that is going to be the topic of our next video. So for this week, it's a very short one. I will post this script in the chat. It's pretty simple. But what I've generated here, if you think about it, is a very simple technique that can apply to almost everything that's out there, right? So as long as you have your baseline K file, in this case, my baseline K file is this thing, right? I have my baseline K file. This baseline K file is going to be read by every single situations, and then I'm gonna parse it through this template, and this template is gonna call different case IDs with different parameter values, right? And then for situation in which I have a large-scale DOE, I can use this Python script to generate a much larger case parameter batch file. And this batch file, all you have to do is open the ls run, and then call this file right here, and it's gonna run each of these cases sequentially. And then overnight, you'll run all 53 cases very, very quickly. And then that, as the topic of the next video, I'm gonna post-process it with a post-processing template, which is going to look at all the stress value, the D3 plots, any kind of curve we want to look at. Whatever they may be, there are ways to post-process it in an automated way. And with these two videos, my hope is to construct a very, very focused workflow that can be applied to a lot of different situations. All right, hopefully this is helpful. Thank you very much.